Hello, welcome to the review for PA5. The goal of this assignment is to teach you everything that you need to know to understand fundamentally what is a hash map and why is it useful. So I'm making this video because, well, if you've made it this far in the class, you're almost all the way there. So, kudos to you. But I'm making this video because historically, this is the most difficult assignment for students, and I think it's for good reason. A hash map is arguably one of, if not the most data structure to understand as a computer scientist. So we don't really spare you on this homework assignment. It is quite difficult. Um, Again, that being said, I think if you've made it this far in this course, you definitely have it within you to be successful on this assignment, figure everything out, and take a lot from it. So the motivation for this video is to kind of give you some background, like what is a hash map, why is it useful, why are we teaching you this, but then also uh, what do you need to do to get credit for this assignment, like what it is that we are expecting, and then how I might approach this problem. I'm going to, share some insight with you. Okay, so the first thing that we're going to do is we are going to look at the technical documentation. So this is going to be something of a speed run. I highly encourage anyone watching this video to thoroughly read this technical documentation just so that they know exactly what it is that is being asked of them. I think generally that's pretty good practice. Again, I'm trying to keep this video reasonably timed, so it's going to be something of a speed run. But yeah, so let's get started. So Lake 221 assignment unordered map, you're greeted with this landing page. Go ahead and clone this repository to your computer and then start working from there. Unordered map. So this paragraph gives you some motivation. Essentially, the paradigm behind an unordered map is that you are sacrificing space complexity for time complexity. An unordered map takes up a lot of space, but it is very quick, especially with insert, erase, and search. Because it is such an important data structure, the standard library in C++ already offers it. So we're not doing anything novel. Actually, if you click on this link, it can take you to the C++ documentation page where you can see the existing C++ unordered map. And huge hint, the goal of this assignment is to rebuild what the C++ library has already built for you. So the functions that exist in the standard library map are one-to-one exactly what we expect you to implement. There are some differences. The standard library goes into a bit more depth than we do, and you won't have to worry about resizing your array or anything like that. But yeah, if you're curious, definitely poke around in the unordered map documentation. Continuing the speed run, we see a table of contents. And these links all work. So if you want to go to a certain particular part of the documentation, this will take you there. The first thing that we are going to see, I think, is a description of some of the tools that are already given to you and the structure of some of the data, which I will go into more detail later. So fundamentally, unordered map is a lot like list. You're going to see this a lot. The iterator is very similar, and then also the data type is an STD pair where we have a key and a value. So one problem that we had with the list programming assignment was that access was very slow because to find something in that list, you have to do a lot of traversal. The unordered map is a upgrade to the list in the sense that you no longer have to traverse through the entire structure to find what you're looking for because we define a function that maps inputs to outputs. So if we know what we're looking for, we can tell you exactly where in the data structure it would have been stored if it's there already. So how does making certain nodes grant an advantage to, how does marking certain nodes grant an advantage to the unordered map? Well, these nodes are marked because they mark the start of a new hash code within a map. We're going to see this in very great detail. A hash code is the result of running a hash function. For the purpose of this PA, you can think of the hash function somewhat like a black box, right? If we have key value pairs, we give a key to the hash function. The hash function gives us a very big number. We pass that very big number to this function called range hash, and then that will spit out an index in the data structure in which we might look for something that had that particular key. So we have defined a mapping from a key to an index in the data structure. which essentially these two paragraphs, that's what it's trying to tell you, is important about the hash map that you don't get with the list. Some other details in here, you're going to have private members for computing the load factor. I think you'll learn about this in lecture. I don't want to talk about it. And in computer science, the unordered map is also called the hash table by chaining. It kind of gives you a little bit more detail about what's going on under the hood. Specifically for this hash table, we're going to resolve collisions with the chaining method, which again is just another similarity to the list assignment that you have already done. Lists in C++, the suggested architecture is a single long list, and the hash function just, skips you ahead in that list. For the purpose of this assignment, we're doing it a little bit different. Don't worry about it. And then after these paragraphs of motivation, it is right into function definitions. So these are super helpful if you are stuck on a function and you want to see if maybe there's like a hint about something that maybe you've overlooked, or you want to know specifically like what this return type is, why it is that way. So the first functions that they're going to list out here are the bucket functions. So essentially, given a key of an element, where does it exist in the data structure? That's what these functions are telling you. They provide some helpful information in the documentation, also like the time complexity for the operation, and then a list of the test cases that are going to call this. This list is not exhaustive, so it's potentially possible that you would have a function here in the GitHub, and it's important for a function that doesn't appear here. Don't worry about it. It's a vague idea. Past the bucket functions, we have the find functions. So given a key, actually find it in the data structure, kind of similar to bucket, similar idea. As you can see, the bucket functions, there's three of them because there's different parameters that you can use to represent your data, right? So you either have the hash code, which is the output of the hash function, you have the key, or you have the key value pair, and all of those should be able to help you find what you're looking for. Likewise for find, the same function is defined with different sets of parameters representing the data. You'll notice that the return type of the find function is a pointer reference, and I'm going to talk about this in detail later on. See, continuing the speed run, we have insert into bucket, which is a helper function for insert. So the actual logic for inserting something into the hash map will be done here, and then this function will be called inside insert. Likewise, we have move content, which this is your move constructor. Move constructor. This is the function that defines move logic, and you will call this inside move. Next, we have the rule of 5. So this is the constructor, the destructor, copy, move, copy assignment, move assignment. We've got the clear command, and this is essentially the bulk of your destructor. We're going to have some getters like size, empty, bucket count. We're going to have iterator functions, so cBegin, cEnd, begin, and end are going to return iterators to the respective first and last elements, or end will be one past the last element of your data structure. We're going to have local iterator begin and local iterator end, and I'll explain the difference between the two types of iterators further on. We're going to have some public functions, so bucket size, load factor, bucket. These are all public as opposed to private. Here's our actual insert function. We're going to have insert by move and then insert by copy. We're going to have a public find. This is the access operator. This one is weird. When y'all implement this one, go to the docs and actually read this, because what it's expecting of you is strange. Let's see, we've got two different erases. Again, you can have either an iterator to an element that you're erasing, or you can know the key of the element that you're erasing. Either works. We've got a private helper function. So this is a print function, which you will not be tested on, but it does help in case you need to debug. And then we have the unordered maps iterator. So for this assignment, there are two iterators. There's a local iterator and a global iterator. So when we resolve collisions using the chaining method, we are essentially creating a linked list such that elements that were all mapped to the same index in the outer structure form a linked list, right? That's how we resolve the collision. We just say, everything belongs in the same place. To iterate through that structure, we use the local iterator. to iterate through the entire structure, regardless of which bucket you're looking at, you use the global iterator. So in this assignment, these things are referred to differently. I believe the global iterator is also called the basic iterator, and the test cases are kind of inconsistent with the naming conventions, so don't get hung up on it. But this one essentially should jump from bucket to bucket and iterate lists in order, just the way that a linked list would. You can see we've got prefix increment, postfix increment. This one is going to be tricky, specifically for the global iterator. More on that later. We got all of our iterator functions, which y'all have seen this before. And then the local iterator, probably the easiest thing about this assignment, because this is almost copy and paste from the linked list. So we got more iterator functions. And then at the end, there's like a little bonus. Well, I mean, it's not bonus, you have to do it, but you actually get to define some hash functions for yourself, and this is pretty much copy and paste pseudocode. It's super easy. And then here's some helpful links. So I think these are good. Geeks for Geeks is normally really good. I would actually check these out. Some more motivation, some application of unordered maps. If you've used LeetCode ever, you already know that this is important. Some information about running the tests. And then here's a little map of the order in which they suggest that you run your tests. We're going to talk about that later. And then the files that you're going to be modifying are unordered map.h. And then at the very end, you're going to touch hash functions.h. But the vast majority of the work that you're doing is going to be in unordered map. So that's my little speed run of the technical documentation. I think technical documentation is super important, especially for the reason that you can do this. You can control F, whatever you want to see. So imagine I have a question about the access operator. I'm not kidding. This is probably the best way to answer your questions. Literally type in what you're looking for, and boom, here's a whole paragraph worth of information. So don't sleep on the technical docs. Super important. Okay. So for the next part of the review, this was the technical doc speed run. The next thing I want to do is I want to like actually draw out what is happening in the hash map and kind of make some visual sense of what's going on. So I'm going to draw some pretty pictures. So within a hash map, we are going to store data in a specific structure, hence the name data structure. So if we have data, which in this case, I'm going to say is represented by a key value pair, then the way that we put this data into our hash map, which I'm going to draw down here, right, we've got some kind of array. So the way that we get our data into this array is we take the key and we pass it to some kind of black box function that we call the hash function. So we don't actually need to know what happens in this black box, but we pass the key into the black box function. And then the output of the hash function is just going to be some really big number. And in this assignment, we're going to call this the code. This is your hash code. So essentially, once we have passed the key from the data into the hash function and we've developed the code, we then need to map this code to the array that we're looking at. So we take the code and we take the modulus, the size of the array, I'm going to call it m, and then this is going to return the index at which you either insert, find, erase, whatever it was that you were trying to do, right? So imagine it spits out for a specific key. So imagine this is just bogus, but for some key value pair, it says, put this at index 4. So at this 1, 2, 3, 4. And this assignment, you would be like, okay, I store the value here. So this is kind of the long and short of what a hash map does. Specifically in this assignment, we are going to be looking at an array of pointers, and then those pointers will all be heads of potential linked lists, right? So it's going to start as an array of null pointers. and right. So imagine we insert another key value and it says put something at 1. Imagine we put something at 6, put something at 2. Imagine we map another element to 4. We just chain it. We just chain our elements, so on and so forth. All is well. And essentially, this is what the data structure is going to look like as you progress. It is going to store elements like this. So some really important notes to make. First off, the size of this array has got to be prime, and that's really important. And I think it'll be discussed in lecture probably why that is the case. I mean, if not, I apologize. See, other important notes are just terminology. So in this assignment specifically, this data that I just circled right there is going to be represented in a struct known as the hash node. And the hash node is going to have its own key value pair, but instead of being called key value nominally, it's going to be key and then some templated t, right? So y'all have seen templates before. This is a templated structure. And altogether, this data is known as the value type. So when I said key value earlier, don't get confused, because when we say value type in this assignment, we are actually referring to the pair, which is both the key and the data, which is stored as t. Each hash node is going to have its actual data or value or whatever it is, and then it's also going to have a pointer to the next value in the linked list or whatever it is, so on and so forth. Specifically, the array that we're looking at right here, this array is called buckets, and it's a private member that we're going to see. This is a buckets array, and the type of this array is going to be a hash node pointer. And that kind of makes sense, right? Because we've got a pointer to an array of pointers. So it is going to be a hash node pointer. So yeah, y'all are going to see this. The size of this array, I'm making a mess, sorry. So the size or m or whatever it is, the size of the array is going to be known as bucket count. And this is not to be confused with underscore size, which is the actual number of 1, 2, 3, well, I can count, so on and so forth, the actual number of elements in the structure. Some other important terms, this black box function right here is actually another thing that gets passed in as a parameter. This is known as underscore hash. We're going to see that in a second. This modulo function, this right here, is already done for you. This is called underscore range hash. Okay, so I really hate to scare you with all this information. This is just kind of like a little map of PA5 so far. And before I disconnect from my iPad, I want to do some examples so that you can see actually what's going on. So imagine we've got this array, right? 1, 2, 3, 4, 6. And we want to insert something to the array. Well, actually, let me draw some data already being here just to make it a little bit more interesting. Okay, so if we want to insert something to this array, first we have to go through the process that I mentioned before. So we've got to find, the hash code, and then we take the modulus of the bucket size, and that'll give us an index. But assuming we know which index we want to insert at, we're going to insert at some index, right? Assuming we know that we want to insert at this index, what we're going to do is essentially push to a linked list. So if you remember linked list as an abstract data type, if you want to, the most efficient way to push to a linked list is actually to insert at the head, right? Because you don't have to actually traverse the rest of the structure. So if we were to insert at this index, we would do so by essentially pushing at the beginning of the head. So let me see if I can, move these things. So an insert to the linked list would kind of look like this, right? If we insert to an index that doesn't have anything yet, just going to be pushing to an empty linked list. Or if we were to insert over here, if we were to insert over here, again, we are just pushing to the beginning of whatever chain already existed there. So that's kind of the long and short of insert. Another important note is that this is not in sorted order. This is not sorted. So it doesn't really matter. You don't have to insert everything sorted. You just kind of always automatically assume that you are inserting. Ah, what did I do? You just kind of automatically assume that you're always inserting at the beginning of the linked list, no matter what. So insert, I think that about covers it. Let me do an example of erase. So again, similar to insert, I think it's helpful to just kind of see a picture of what's going on, maybe help you understand actually what is being expected. Let's see. Okay, yeah, so for erase, imagine we know the index of the element that we're trying to erase. Let's say for simplicity, at first we're erasing the element that's at this index, right? We're going to do so by first searching. So, we've got to find the index, but once we found the index, we erase from the structure by dealing with whatever pointer came beforehand and then deallocating the memory for the node, right? So I'm going to do that again. So we have some pointer from our structure to this member, and we have to deal with that pointer, we have to invalidate it, and then we have to deallocate the memory. So if we are trying to, let's say we had two elements in this chain, right? If we are trying to erase the second one, not just the first one, then again, what we have to do is we have to take this pointer, which, we have to take this pointer, we have to invalidate it, we have to make it null pointer, and we have to deallocate this memory. Or let's say, I'm going to do one even trickier. Imagine this chain is a little bit longer, right? If we're inserting, if we're erasing this node, well, we have to first take care of this pointer, and then we have to deallocate this memory. And that's going to look remarkably similar to PA3, right? So the first thing that we're going to do is we're going to take this pointer, and we're going to say, oh, actually, you point here now. And then we're going to delete this memory, and voila, chaining linked list insert performed correctly. And just to reinforce that one more time, I'm going to delete this element just to absolutely make y'all confident. So first thing we have to do is fix this pointer. So the pointer that was coming into the current element now needs to point to the next element. And then we need to deallocate the node that we were trying to erase, and boom, issue handled. I think one really important trick for this PA that was kind of introduced very briefly in PA4 is the pointer reference. So for some more context, when I say you find this index, you find the index by using the actual find function. And the output, let me just draw this. The output of the find function is a hash node pointer, and I still can't do an ampersand, so please, have some forgiveness, is a pointer reference, right? Which means that, say we're trying to find this node that I colored in here, right? Imagine this is the node that we're looking for. The output of the find function will be this pointer. It's not a pointer to the node that we're looking for. It is the pointer from the data structure to the node that we're looking for, right? So I'm going to say that again, right? We're not giving a pointer that just happens to be the address of whatever node that we're looking at. When we're passing a pointer reference, we are referencing the actual pointer that we used to find the node. So given that, let's say find returns, in this case, I'm just going to call it pointer, and it's a reference. if we have found the node that we are trying to delete, this is pointer. That is actually pointer. So when I say we need to correct the pointer in front of it, we don't have to go again and search for this pointer because, you know, the one that I circled, we can just say, hey, you equal this now. And assuming we stored the information, so, you know, we call this, I don't know, save pointer or whatever. Assuming we stored this information, we are then now safe to deallocate this memory, invalidate this pointer, and voila, issue handled. So that is kind of the long and short of hash maps, kind of some of the terms that you're going to see. This is kind of maybe what insert is going to look like, and then kind of maybe what erase is going to look like. One more detail that I want to mention before I leave is that there is a, let me just draw another array. There is another variable that you're going to have to keep track of during insert and erase, and that is called head. So as you insert things to your list, head is going to point to whatever the first element happens to be, right? So if you have, if you're inserting, like for instance, something that is earlier in the structure, you have to be careful that if you insert something that is kind of in this region before head, you need to update head to now point to whatever the most recent thing is, right? Or if you do another insert, and let's say we do another insert, we insert a new element here, well then now head needs to point to this new one, right? And so you've just got to keep track of that dynamically, kind of just how like keep track of size as time goes on. So that's kind of an important note, I think. And then likewise for erase, if we happen to erase the node that was the head, we would have something that looks like this now. Well, we need to fix that by replacing the head pointer. So that's kind of all I have to draw as a diagram. Hopefully that was helpful for at least somebody. Now, while I still have your attention, hopefully, we are going to do a quick step through of the starter code that we're looking at. So let me open up VS Code. Let's see. Okay, yes. So when you start this assignment, you're going to see something that looks like this. You're going to have your starter code files. You're going to briefly touch hash functions, CPP. It's not the highlight of the assignment. Most of the show is done here. About 200 lines, I think, when you get it. And then your tests are going to be in this folder, you know, nothing that you haven't seen before. So let me real quick step through this code and make some high-level remarks. So we've got class unordered map. This is the class that we're defining. This is the unordered map. You can see it is a templated class, and you can see all of these types that are passed into the template. Most notably, we have the type name key and the type name t. So if you watched the earlier part of this video where I said it's key value pairs and it's technically key t as value type, that's what this is, right? So this is your key and this is your value, but for the purpose of this assignment, those two are going to be represented as std pair key type mapped type. And if you look here, mapped type is t. So when you see value type in this assignment, really that is referring to the combination of both key and value. But for this assignment, key and value together is the value type, and you're going to reference the individual key or the individual data as value.first or value.second, whatever it is. So that is initially, I think, pretty important. We're going to have our private struct. So this is the node struct. This should be very similar to the PA3 linked list node struct. As you can see, we've got our value type val. This is kind of like our data, and then a pointer to the next node. We've got some constructors, but I don't think you need to worry about those. Next, we have the private members for the unordered map. So the unordered map is going to keep track of how many buckets are in that array, right? Like each array being the start of a new linked list. Bucket count is how many of those are there. We're going to have hash node pointer buckets. This is the actual array. We're going to have the pointer to the first node. We're going to keep track of how many elements are in the list. And then these two functions just get passed in from, I think they're templated. Yeah, they're templated, so you probably won't need to worry about these more so than just saying hash is equal to hash. Another important thing to note is that a lot of these private functions, in fact, I think all of the private members and I think all of the private functions start with an underscore, the down underscore. And that is, just organizationally is kind of helpful, right? So this private function right here called range hash, you can see it starts with an underscore. That means you can only use it from within the data structure. It's not public. It's not, you can't interface with it. This function is going to return the code, which remember was some huge number modulo the bucket count. So you can use this later on. Next, we have the definition of the basic iterator. So this is the difficult one. This is the one that jumps around from the different buckets to get all of the elements, right? So a basic iterator could start from the first thing in your hash map, iterate, like do a complicated iteration all the way through and end up at the last thing at your hash map. As you can see, we're going to have the actual pointer that the iterator contains, and then, your basic constructor, pointer operations. This is the difficult one. We're going to talk about this in a second. Also, another peculiar thing about the iterator is that you store a pointer to a map. I'll talk about this in a second. Here's the easy iterator. This is the linked list iterator. Not too much to see here. We've got some private helper functions, and as you can see, they all start with the underscores. We're going to talk about these in a second. We've got the rule of 5. We've got some gimme functions. And then the real difficult ones, I think, for this assignment are going to be the insert. The iterators are tough too a little bit. And then erase is non-trivial for sure. And then here you have this helper debug function, which I never had to use, but maybe someone will find it useful. Who knows? So first thing I'm going to do is I'm going to kind of spell out a roadmap. So I'm going to call this like order of functions to complete. And this by no means is canon, and it could be done in whatever order you want. I just personally, I recommend the first thing you do is the constructor first, and I'll talk about this in a second. I would also recommend that next you do the private helper functions. And this is going to be important because that'll help you build your local iterator, your global iterator, and also your insert function. Once you've done your insert function, I would then focus on your erase function. And the two of these are kind of the building blocks that you're going to use to implement your rule of 5. This being the constructor, not just the constructor, this being copy and move constructor and copy and move assignment, destructor, so on and so forth. And then do the hash functions, which are in this other file at the end. And the hash functions actually don't affect anything else in your code, so don't worry about these until the end. So let's first take a look at the constructor. So this right here is your constructor. So let me see. Hold on one minute. Pull it up. Sorry for the delay. Okay, yeah, so here's your default constructor. And as you can see, you've got your hash and your equals function already passed. So what you need to do in the default constructor is basically construct your buckets array. So construct buckets array, and you're going to have to actually allocate space for that. A huge hint is that the size of the, let me be consistent, the size of the buckets array has to be prime. And I believe that there's a built-in function called next greater prime, and I think it's got an underscore, which essentially is going to tell you, like, if you're trying to construct a hash map with a certain size, you're not guaranteed that this is a prime number, so you just automatically assume you have to make it equal to the next greatest prime number. And again, I think in lecture you probably learned why it's important. And then also, one last thing is make sure to initialize the buckets array with null pointers. And that can be done with like, you know, see like some kind of pointer type new node is equal to pointer uh, new pointer, and then you know, your size goes here. This is just basic C++. If you put an open and close parentheses here, that's kind of a shortcut for setting everything equal to null pointer. But this is your constructor. And let's see, one other important thing. I'm only going to make this point once, or maybe twice, but so when I say do the constructor first, that doesn't mean you type in the code for the constructor and then it'll just pass right away. So if we actually do some digging and we look in the constructor test case itself, so this is constructor, and as you can see, the first thing, well, one of the first things they do is they initialize a map. You see this uppercase U, uppercase M clues you in that this is our data structure, so they're referencing our actual map. This is calling the constructor within size, whatever it is. And to test it, they do map.size and map.bucket count. Map is our map, so size is our size function, and this is our bucket count function, which means that in order to even pass the constructor case, you have got to fill in the, and I don't know where it is, but you've got to actually fill in the size and bucket count functions. And this is true a lot of times in this code. Like when I say do the constructor or do the iterator, it doesn't mean like that's the only thing that the test case relies on. In this case, it is a little bit more than that. So once you've done the constructor, I would do the private helper functions. And where are these? These are listed here. So I would start with your bucket functions. I think bucket.cpp actually tests these. So remember, this is kind of the logic mapping keys to indices. I hope I spelled that right. And so essentially, the size type, it's asking for you to return an index given some information about the input. So you either have code, which is like the really large number, you have a key, or you have a key value pair. And from all three of these, you should be able to get an index in your buckets array. And just remember that the code is equal to whatever hash function that you have called on your key. And that's the same thing as like whatever hash function you have called on the value dot first, because the key is the first element in the pair. If you're clever, you can write these three functions in such a way that you do I think it was range hash to actually do the modulus, and some kind of thing goes in there. So if you're clever, you can write these three functions where you define it once and then call it twice, which I think is probably the best way to do it. Find, super important that you're returning a pointer reference. This will be super helpful in the erase function. Insert into bucket. This is your helper for the insert function. So see if I had any notes on this. So yeah, so let me write some stuff for find. So for the find function, it's assumed that you know what bucket to look at. And actually, I'm going to collapse these because it's the same function just with two different buckets. So assume you know what bucket, right? So if you're given a key, then you could pass this key to the hash function, and that should tell you what bucket you need to look for. So essentially what you're doing is you're looking within a linked list for a certain element. And also probably an important note is that when you're looking for, in this case, a key, you have to use the equal function that was passed in earlier to compare elements, right? Insert into bucket. See if I have any notes about that. Yeah, I'd say like I said before, it's important. So maintain the head member. That's probably important. And then also insert at beginning, not sorted order. So that should be some good start. And then move content. Y'all have done move functions before. I don't think I need to talk about it. Okay, next we've got local iterator, global iterator, and insert. So I think this is unequivocally the hardest part of this assignment, just specifically because the test cases are really misleading. Like the autograder is really, 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 really misleading. Like it's possible that you would pass the find and global insert test case, but your global iterator doesn't work. Or it's possible that you would pass the insert and local iterator test case, but neither your insert nor your local iterator works fully. So while these test cases provide you a framework to know more or less are you doing well, they are not the be all end all. And so if you're confused and the test cases seem like they contradict, maybe they do. It is up to you to figure out exactly what is going wrong, and you probably have to do some extensive debugging. That being said, local iterator cannot be tested without insert. Global iterator cannot be tested without insert, and insert cannot be tested without global iterator. So it's kind of like a very, very messy interconnected structure. So if we actually look at one of these test cases, like insert and, or actually, let's just look at iterator.cpp. This test case, I'm sure it calls insert. Okay, maybe this one doesn't. Maybe iterator doesn't call the insert function. But for instance, if we look at like insert and local iterator, as you can see, to test the insert, you've got to have the iterator already completed. Or if you look at bucket iterator, this one is going to call this is going to call insert. Yeah, so you have to have insert to be able to test your iterators and vice versa. So you kind of have to do them more or less blind. But anyway, so some information about these iterators is the local iterator. This one is easy. This is basically linked list iterator. So don't get freaked out. Oh, two iterators. Don't worry. This one should be a piece of cake. Difficult one is basic iterator, global iterator, the one that hops around. So the unordered map is declared as a friend class within the global iterator. And the reason that is done is because the global iterator has the unordered map as a member. How does that work, right? I thought that global iterator was defined within unordered map. Why would you have map within the iterator? Well, the reason for this is, remember the array that stores the linked lists, right? The buckets array. You might potentially have to hop from the end of one linked list to the beginning of another linked list if you are iterating through the entire structure. And the only way that you can do that is if you have access to that buckets array. So your global iterator needs to have access to that array so that it can do the hops. And for that reason, you have got a constant pointer to the current map that you're iterating through, just in the case that you need to make the hop. And that hop will be done here. So the prefix increment, I strongly recommend that you fill in the, I'm actually going to make a comment. So write the prefix increment and don't write it twice. Write it once and then call it down here. So call your prefix here. And so I think I have maybe some notes as to what needs to happen exactly in the global iterator. So there are a few things you need to check for. So first, if you check, are you iterating in the middle of linked list? Because in that case, like if node next is not null pointer, big deal. It's trivial, right? You just move to the next node. No big deal. Most of the worry is going to be handle the case jumping from one list to another list. So that's really going to be the difficult thing. And essentially the idea here is you're just going to search along buckets until you find something non-null. So this is one of the more difficult pieces of this assignment. So good luck. Good luck on this. Spend some time thinking about this. Again, local iterator is easy, more or less. I guess the only note that I would make is that don't do this twice, right? Do the prefix and then define postfix as a function of prefix. And make sure to not increment if the next node is null pointer, right? Basic linked list stuff. Okay, so those are the iterators. We talked about insert into bucket. Let's talk about the actual insert function. So the insert function, there's two of them, as you can see. One of them is going to take, this is insert move, and then this one down here, this is going to be your insert copy semantics. And right off the rip, you can notice that it's a really strange return type that we have for this function. The return type is going to be an std pair of iterator and bool, and essentially the iterator, so the iterator to the element you inserted slash found, and I'll explain that in a second, and then bool of whether or not you inserted anything. So insert, first you're going to have to call find. Actually, let me make a note of that. So call find to find the place in your hash map that you need to do the inserting. If something is already there, then you return an std pair of the thing that you found and false, saying I didn't insert because there was something already there, and false for, I didn't insert. If find returns a null pointer, then you insert, you make a new node using the insert into bucket. So I should make a note. The memory allocation actually happens here. So your new keyword should be in here. Also, I would say probably size ++ should be done here too. So the actual dirty work of the insertion should be done in this function, and you should call that here. Maybe another thing to look out for is the function std make pair will help you with your return type. And essentially, it's very similar. The move and the copy inserts are very similar. Maybe one thing that you might have noticed, or that you will notice, is that we have both copy and move semantics defined for inserts, but for our insert helper function, we only have move semantics. How do you get around that? Well, that's a challenge. I'm not going to give it away entirely. So how do you use move semantics here, right? Because we defined our insert helper to only have move semantics. So I'm going to say a huge hint, construct and R value. So imagine we've got some kind of value type T, right? And then we put our value in here. We can then pass this to insert to bucket. So insert to bucket, or whatever it is. I'm not sure exactly. So instead of actually passing value, we can just move in whatever this is, and that solves that issue. So that's kind of insert, kind of the iterators. Let's see, erase function. Where are we? Erase function. Should be down here. And like some of the other things in this assignment, there are two erase functions. It's important to note, don't do both of these. Like, do one and then write the other one to call the other one. So you can either write the iterator erase and then call iterator erase from within the constant key erase, or vice versa. You can do it both ways, but pick one, fix one, and then map that one to the other one. So the iterator erase is going to be return, and let me see. Actually, let me pull up my notes so I'll make sure I get this absolutely right. Let's see. Yeah, so find the node, save a reference to it, and then return. Actually, I'm not sure. Returns an iterator following the last removed element. Yeah, there you go. Okay, so return iterator following last removed element. What else to know about the erase function? So think about what you're doing with the head private member. See, in this case, return end if there's nothing to erase. So actually, let me make it, first you have to find your node, and let's see, return to completion status. Okay, so another thing to think about for the erase function is you're given an iterator position, right, or a constant key, and uh, you have to find this in your data structure before you can remove it. And if you are unable to find what they are asking you to find, in this case, you return end, and in the size type case, you return 0. If the erase is successful, then you return an iterator following the last one, or a 1. Uh, okay, yeah. Also important for the erase function, think about the pointer reference. Helpful, helpful in this case. Okay, so erase and then rule of 5. We already talked about the constructor more or less, which is here, and then you've got your destructor, which is mostly just call clear, and then deallocate buckets, buckets, and then you got your copy constructor, you got your move constructor, and then likewise you've got your assignments. This is copy assign, move assignment. These should be the easy ones relatively. Clear should call erase until you can't anymore. Size and empty should be one-liners. Bucket count should be a one-liner. These return iterators. So these return global iterators, and then these two return local iterators. So sorry to be blowing through this, y'all. I just want to be respectful of your time, so on and so forth. So another thing to point out here is that the global iterators are going to have these begin functions that do not have parameters. So as you can see, nothing is passed to these. To reference the begin and end for the local iterator, you have to actually pass an n, which is n is the index of the list to iterate, or in this case, return the begin or end of. Bucket size, there's a few ways to do this. Load factor, there's a few ways to do this. Let me just give you a hint. You need to do a static cast into float type. Look up how to do that probably. Access operator. This one is strange. Read the docs. But the long and short essentially is you try to find key. If you can't find key, you insert a fake key, kind of. And then also notice this return type here is t, which is, as we said, this is like the value of the key value pair. So return value dot second or slash t, whatever, however you want to think about this. And I think that about covers it. Yeah, I think that about covers it. And then for your hash functions, this should be a breeze. This is really trivial. Okay, so sorry if that was a lot to take in. Um, I hope there was at least some useful information in this overview. PA5 is difficult, but it's not impossible. If you've made it this far in the course, don't give up on yourself now. You can make it, I promise. I don't know what else to say. Reach out to me if you have any questions. Best of luck.